everyone. We are going to go over Bohr Rutherford diagrams today. And the reason that we're going over this lesson is because it's probably the most important lesson of grade 9 chemistry. So here we go. Bohr Rutherford diagrams. These diagrams are used by scientists to create a visual representation of arrangement of subatomic particles in an atom. So what subatomic particles are the protons, neutrons, and electrons in the actual atom. So Rutherford's model of the nucleus is combined with Bohr's electron arrangement model in a diagram that shows the number and position of all three subatomic particles found in the atom. So what we can do here, we have standard atomic notation, and in this notation we have the symbol in the center, and then to the top left we have the mass number, which is the total number of protons and neutrons together, and in the bottom left we have the atomic number, and the atomic number for subatomic particles is the number of protons. So this will be important information when we're actually trying to figure out the three different pieces. So how can we use the mass number and the atomic number to help us figure out information? Well, the atomic number is the total number of protons, which means it is also the total number of electrons, because positive and the negatives have to balance out to equal 0 for a neutral atom. And the mass number subtract the atomic number is equal to the total number of neutrons in the atom. So this will be important information when we're working out Bohr Rutherford diagrams. So where do we find the atomic mass? So in our periodic table, we find the atomic mass below the element name. So when you read the symbol, you'll see the name, and then below that name will be a number, and that is your atomic mass. So where do we find the atomic number? So the atomic number on a periodic table is above the element symbol, and that's usually in the top left corner. So the big thing about atomic structure, electrons are arranged in energy levels, or another name for energy levels is orbits or orbitals, around the nucleus of the atom. So the nucleus of the atom is where our protons and neutrons are found. So outside of that nucleus is where we're going to find the electrons. So the electrons are broken up into different levels. So, and those levels we call shells. So each shell can only hold a certain number of electrons. So our first shell can only hold 2 electrons. So if there are more than 2 electrons, then we have to go to the second shell. But the second shell can only hold a maximum of 8 electrons. So if we have more than 10 electrons in our element, we then have to go to the third shell. And that third shell can only hold, again, 8 electrons. So now if we take a look at this total, this is only 18 electrons in total. So if we have more than 18 electrons, then we have to go to the fourth shell, and that fourth shell can now go all the way up to 18 electrons. But in grade 9, we only take a look at the first 20 elements. So we won't go too high in the fourth shell. So now with respect to electron configuration, we can actually describe how many electrons we have in each energy level. So the order of the number of electrons in each energy level. So we have, in the diagram, we have our nucleus, and over here we would write the number of protons and neutrons, and then in each energy level, we would then have the total number of electrons that that element could hold. So if we look at nitrogen, nitrogen has a mass of 14 and an atomic number of 7. So since we have an atomic number of 7, that means we can only have 7 electrons. So if we go through the different energy levels, so the first energy level can only hold 2 electrons, but I need 7 in total. So that means we need to go to the next energy level, which is the second shell, and then we can then use up the rest of our 5 electrons in the second energy shell. So let's take a look at some examples. So calcium, oops, too quick, has 20 electrons. So for 20 electrons, we need to then fill in each subsequent shell. So we're going to have 2 electrons in the first shell, all right? So that's only 2. Then the second shell can hold 8, but that only gives me a total of 10. So I need 10 more, but the third shell can only hold 8. So that means we have to go all the way to the 4th energy level. So that's why it's going to be broken up into 2, 8, 8, 2. First, second, third, and then the 4th energy level or electron shell. So sodium, Na, has 11 for its atomic number. So it's got 11 protons, which means it also has 11 electrons. So then that means I need 2 in the first energy shell, 8 in the second energy shell. That gives me a total of 10, which means we need to go to the third shell with that leftover 1. So oxygen, all right, we have 8 for its atomic number, so 8 protons, but also 8 electrons. So if you think about it, before I pull up the answer, we're going to have 2 in the first shell. That leaves me with 6 electrons. So am I able to keep those 6 in the second shell? Absolutely, because we still have space left over. Okay, chlorine, we have 17 for its atomic number, so that means we'll need 17 protons and electrons. All right, so if we start working through the energy levels, we have 2 for the first one, 8 for the second one. That means I still only used up 10. I have 7 left over, and then that can all get filled in the third shell. Okay, silicone has 14 protons and electrons, so that means we're going to have 2 in the first shell, 8 in the second shell, and then what's left over goes in the third shell, which is 4. So boron has an atomic number of 5, so that means we have 5 protons and electrons. So that means we have 2 electrons for the first shell, and then we only need 5, so then the leftover 3 can then go in the second energy shell. Okay, now we're going to look at how to draw Bohr Rutherford diagrams for electrically neutral atoms. So in grade 9, we look at electrically neutral atoms. In grade 10 and 11, you might look at a different concept where they're not neutral. So we want to write the standard atomic notation for each element. You'll need to use the periodic table to help you figure out the atomic and mass numbers. So for chlorine, here we would have pulled the symbol from the periodic table. All right, we would have taken the mass number 35 from the periodic table and the atomic number 17. All right, so when we write the standard atomic notation, it makes it a lot easier for us to then figure out the rest of the information we need for Bohr Rutherford diagrams. All right, so to figure out the protons, electrons, and neutrons, all right, and just a friendly reminder, we're dealing with chlorine with 35 for its mass and 17 for its atomic number. So protons is your atomic number, so that's 17. Electrons is the same as your atomic number, so that's also 17. And then neutrons is your mass, subtract your atomic number. So then 35 minus 17 leaves us with 18 neutrons. Okay, so now the next step is we need to draw the nucleus and write in the number of protons and neutrons. So now here we have 17 protons, 18 neutrons. And then the last step, we need to draw in our energy levels and then draw in the number of electrons in each orbit. And there is a very specific way in which we draw in the electrons. If you draw them in a different order in which they are paired off, and they don't match up with the answer, then your electrons are incorrect because they behave in very specific ways. So our first electron goes in the first shell here, and then you have the second one in the same shell, but it pairs off because it wants to have a buddy. Okay, then in the second orbital, we put the third electron, and then the fourth electron goes 90 degrees down. The third electron goes another 90 over, and then the next electron, so this would be the sixth electron, goes all the way on its own, and these four guys want to stay as far apart as possible. Okay, once we go past 4 electrons in that second shell, then they start pairing off. So now electron number 7, right? 2, 3, 4, 5, 6, number 7 pairs off up top. 8, 9, 10. Okay, now we've accounted for 10 of the 17 electrons, all right? But the way they pair off is always the same, okay? And it works the same way in the third orbital. So now we go to electron 11 is going to be by itself. 12 is also by itself. 13 on its own. 14 on its own. Now, after those 4 have been separated, any extra electron in that orbital gets paired off. 15 gets paired off up top, 16 on the side, and then 17 on the bottom. Okay, so the order of that is very important when you are drawing your electron diagrams for Bohr Rutherford diagrams. Okay, so make sure you fill the dots in this order. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if you have any extra orbitals, you follow the same pattern as orbital number 2. Okay, so if we look at fluorine, it has a mass of 19. It has an atomic number of 9. So we're going to have protons is 9. That matches up with the atomic number. Electrons also match up with the atomic number. Neutrons is 19. Subtract 9, which leaves me with 10. Okay, so now if we look at, aluminum, all right, so we have mass of 27, atomic number of 13, so we have 13 protons, 13 electrons, because they match up with the atomic number, and then the number of neutrons is 27, subtract 13, which gives me 14. Okay, and then for practice, you're going to work through the first 20 elements of Bohr Rutherford diagrams. There is a separate video to show you all the answers of how you should be working through each diagram. So if you're unsure, you can follow along with the video and pause as you go in order to check your answer. Thanks for listening. Bye now.